In today's class, we want to talk about the calculations under pH. Now the first one is calculating pH and pOH when concentration of H plus and that of OH minus are given. The next one is calculation of pH of an acid or that of a base. Now an acid can either be a strong acid or a strong base. We can also have a weak acid and a weak base. Welcome to Delzy's online school. Please, if you're new to this channel, please kindly hit the subscribe button, like our videos and share. This is where we actually give you guys the very best. Thank you. So first, let's look at pH and pOH expression. Now pH can be expressed as negative log of H plus or negative log. Now these are the two expressions for pH, their mathematical expression, whereas pOH is negative log of base. So therefore we have that the relationship between pOH and pH is this. Addition of pH and pOH must always give us 14, right? So whether we are solving for the first one or whether we are solving for the second guy, we must make use of this formula. The nature of the question is what is going to differentiate all of them. Now this H plus is hydrogen ion or a proton, right? It is always found in an acid. Now this is oxonium ion or hydronium ion, so it's equivalent to H plus. So sometimes you can see this expression for pH, and in some other cases you can see this expression for pH, right? We're keeping it simple without stress, straight to the point. You understand it. All right, we have the first case. Remember I gave us 3 cases. The first one I said when the H plus and OH minus concentrations are given to us, and the next one I said when they give us when we are asked to solve for that of an acid. Now the first question says calculate the pH and pOH of the solution with the following concentrations. The first one is 0.001 molar H plus, the next one is 0.025 molar OH minus, and the next one is 0.0. If you noticed in this question, they did not give us an acid, neither did they give us a base. They only gave us the values of H plus. Remember I said H plus stands for hydrogen ion. OH minus stands for hydroxide ions. Now this particularly is found in an acid and this is found in a base. Alright, so they gave it to us directly. All we just have to do is to use these values, insert into the formula for pH, and we get our answer. So I'll start by saying, I'll say solution. Now this, I'll say for the first one, concentration of H plus of the solution is 0.001 molar. Now remember that pH is equal to negative log of H plus. So it simply means that anywhere you see your H plus, you're going to impute this value. So this becomes equal to negative log 0.001. If you press the calculator, your pH is going to give you equals to 3. Right? If you press the calculator, negative log of 0.001. So that is the answer to that question. Remember, they did not ask us to solve for only pH. They said pH and pOH, right? But since for the first one, they gave me H plus. Class, depending on the values given to me here, that will determine whether I will solve for pH first or pOH first. Now, if you look at the formula for pH is negative log of H plus. And since they gave me H plus first in this first question, that means I need to first of all solve my pH so I can make use of this H plus, right? After which, I will now use the relationship between pH and pOH to get my pOH, right? If I want to solve for the second one, I'll first of all solve for pOH because what they gave me is OH minus. And after which I'll use a relationship to find the pH. So I'll now say, so therefore, the relationship between pH and pOH is equals to 14, which means if I know any one of them, I can solve for the other one. Alright, so this becomes pOH is equals to 14 minus pH, which is 14 minus 3, and our answer is 11. So therefore pOH is 11. So for this first question here, pH is equals to 3, pOH is equals to 11. That is how we got the answer to that question. Now let's look at the next one, B. Now what they gave us here is actually OH minus, not H plus. Alright, so I'll say the concentration of OH minus. Please notice that this square bracket stands for concentration. Alright, so this is going to be equals to 0.025 molar. Now since OH was given to me, what I'm going to solve first is going to be pOH. So I'll say pOH is equals to negative log of OH minus. So that anywhere I see OH minus, I'll put 0.025. Now when I evaluate that with my calculator, I'll say negative log of 0.025. That will give me equals to 1.6. So I have pOH. So that's the value for my pOH. But remember they said pH and pOH. It doesn't matter whichever one that is solved first. At the end of the day, just get your two parameters. Alright, so I've gotten my pOH. So for me to solve for my pH, I'll say pH plus pOH equals to 1.6. But if you noticed, I've already gotten my pOH. So what I need to get this time around is going to be my pH. So I'll say pH equals to, this is equals to 14, not 1.6. Now this is the relationship between pH and pOH. Alright, if you know any one of them, you can get the other one. So if I make this guy subject of the formula, this one crosses over to this side. This becomes 14 minus pOH. So this is equals to 14 minus, our pOH is 1.6. When you press that, this becomes 12.4. So that is the answer for that. So for this second one, our pH is equals to 12.4 and our pOH is equals to 1.6. Okay, now at the end of the day, once I'm done solving, I'll actually put out the scale on the board and explain to us which of the scale, which number is going to be acidic and which of the number is going to be basic. Okay, so let's stick to this video. Alright, so let's look at the next one, the C. We have C, H plus is equals to 0.00001 molar. Alright, which is equivalent to saying 1.0 times 10 raised to the power of minus 5 molar. Alright, so remember I said whichever one you're going to solve first, it is dependent on what is given to you. So since AH plus is given to us here, the first thing I'm going to solve will be pH. So I'll say pH is equals to negative logarithm of H plus. Alright, now anywhere I see H plus, I'm going to insert this value. This becomes negative log of 1.0 times 10 raised to the power of minus 5. And the answer to that is going to give me 5. Now, let me tell this guy something. Without calculator, I can get the answer for this. Anytime you have values 0.00 ending with 1, right? Now, once you take the negative log of that, whatever the exponential is, becomes the answer. If you press your calculator, you confirm this. Alright? So we've gotten this to be pH equals to 5. So we'll now say, what is the relationship between pH and pOH? So this becomes pH plus pOH is equals to 14, alright? So we already have pH, so our pOH becomes 14 minus pH. So this is 14 minus 5, and the answer is 9. Okay, so we have pH equals to 5, pOH equals to, okay. Now let's talk about pH scale, alright? So let's say this is 7, this is 0, and this is 14. Now this way is acidic. So if I have pH less than 7, that is acidic. The smaller the value of the pH, the stronger the acid. A pH of 1 is stronger than a pH of 2. That means if a solution has a pH of 1 and another has a pH of 2, it simply means that the one that has a pH of 1 is more acidic than the one that has a pH of 2. Okay? So, if pH equals to 7, the solution is neutral. It's neither acid nor base. Then if pH is greater than this, that is basic. Alright, so with this now, I think with these 3 examples, you should be able to solve any questions under pH that is under direct calculation. Direct calculation, I mean, they gave us the value of H plus and OH minus directly. They didn't give us an acid for us to find the H plus, because in the next case that we're going to be looking at, they give us an acid for us to find the H plus, or they'll give us a base for us to find OH minus. Right? So that depends on whether it is a strong acid or a strong base. If it's a strong acid, it's going to be a straightforward calculation. But if it's a weak acid or a weak base, it's not really going to be very straight, but I'll make it to be straight. Okay. Okay. So let's look at the next case. Case number 2. Remember, we just completed case 1. Now, case number 2 is a case where you'll be asked to calculate for the pH or the pOH of a strong acid or a strong base. But the issue right there is that a majority of persons don't really know how to differentiate a strong acid and that of a strong base. But ensure you watch this video to the end, so that when we start talking about that of a weak acid, you could actually know how to differentiate a weak acid from a strong acid. Okay, now before we proceed, what are strong acids? No, I'm not here to define an acid. An acid has general definitions, right? A compound that can donate hydrogen ion, right? Under theories of acid and base, I've already discussed extensively what an acid is and the different theories of acid. Now here we only want to specify on the strong acids and the strong base. Now what makes an acid a strong acid? If they say an acid is a strong acid, what makes it a strong acid? Now a strong acid are acid that ionizes or dissociates completely when dissolved in water, right? For example, you have HCl. When you dissolve HCl in water, you have H plus Cl minus. Now, a strong acid is always going to have this arrow, 2-head arrow. Now, whereas a weak acid, anytime a weak acid is written, you always see something like this. This means reversible. Well, we'll get to this shortly. All right, so I said a strong acid are acid that ionizes or dissociates completely when dissolved in water. Now, when we actually start solving this, I will explain the dissociation here. Now, I said example of strong acids, we have the common ones that we know, H2SO4, HCl, H3PO4. Now, this is also known as sulfuric acid, right? This is also known as sulfuric acid, and this is known as hydrochloric acid, and this is known as phosphoric acid. Take note of that. And I went ahead to say, note, strong acids ionizes completely to give H plus or H3O plus. Take note of that. Now let's talk about strong base. Now whether a substance is a strong acid or a strong base, the common thing between both of them is that they must ionize completely. When they come in contact with water or when they are meant to dissociate, they dissociate completely, not partially like weak acid or base. Now we said strong acids are acids that ionizes completely to produce hydroxide ions. Now let's look at an example that can come under strong acid. If you look at these questions here, they are somehow or somewhat different from the one we did in case 1. This one has acids attached to them, unlike the previous one that they just gave us H plus or OH minus. Right? Now, all of these are strong acids. They are strong acids. How would I differentiate a strong acid from a weak acid? A weak acid will always have Ka value. Anytime you're asked to solve for the pH of a particular substance, right, be it an acid, and then you see Ka. Ka simply means is acid dissociation constant. That means that acid is a weak acid. If it's a weak base, they'll give you Kb. Right? In the next section, we're going to talk about this briefly. All right? So let's just come back to this. Now, the first one says, calculate the pH and pOH of the following solution. Now, these are the solutions. Now, the first one is 0.01 molar HCl. So, I'll say for the A, HCl, now you dissociate this guy. We have H plus and Cl minus. This is a strong acid, so you can choose to add water. You can choose not to add water. It doesn't really matter. Now, based on this, the ratio is 1:1:1. So the concentration of the HCl was 0.01 molar. So since this is 1 and this is 1 as well, this will also be 0.01 molar and this will be 0.01 molar. So having done that, I would say, now listen, an acid will always give rise to H plus. How will I know that this is an acid? It has H plus. H. A strong base will always have OH. Just like I told us previously, a strong base will always have OH. So once you see this, know it's an acid, and when it dissociates, it will give rise to H plus. Right? Now this gave rise to H plus. That means the concentration of our H plus is equals to 0.01 molar. And once you've gotten the value for your H plus, you can now say pH, recall that pH is log H plus. Now this is negative log. Anyway you see H plus, you put 0.01 molar. You can remove the molar first. Now this is equals to 2. Our pH equals to 2. But remember, they asked for pH and pOH, not just pH. So this now becomes pH plus pOH is equals to 14. Alright, so our pOH equals to 14 minus pH. So this is 14 minus 2, which is 12. The B part, so the number 2, we have 0.001 molar H2. Now, how does H2SO4, sulfuric acid or tetraoxosulfate 6 acid, how do they dissociate? Now, H2SO4, when this dissociates, you're going to have 2H plus. Please take note of this dissociation. Anytime H2SO4 dissociates, it's always going to give rise to 2H plus. Because we have 2 hydrogens here, and these 2 hydrogens are acidic hydrogens, right? So they will dissociate as H plus, and then you balance the equation. Here has 2 and here has 1. Okay? Now the ratio here is going to be 1:2:1. Which means if here is 1, here will be 2. So if here is 0.001, here will be 0.002. So we'll say this is 0.001, and this guy will be 2 times 0.001. I am not interested in this because I will not use SO4 2 minus to carry out any calculation. I need H plus because pH, the formula for pH, which is pH equals to negative log. This formula has H plus, so that is why I'm carrying out this dissociation to be able to know the exact value of H plus, so I can substitute into this formula. All right. So based on this, H plus concentration, remember this square bracket stands for concentration, which is denoted, this M, this molarity, this capital letter M stands for molar, which tells that this is the concentration of this guy. So this becomes 2 times this is 0.002 molar. So insert this into your formula, we have negative log of 0.002, 2.7 approximately. 2.7. All right. So we now have pH plus pOH is equals to 14. Remember, we were asked to solve for pH and pOH. So this now becomes 14 minus 2.7, which is 11.3. We have the third one, 0.025. Now this is a base. So what we are going to be obtaining from here is OH minus, not H plus. So this is a base. So I'll say 0.025 molar. So this becomes calcium. OH minus. But if you look at this, we have 2 of them. That is why we are adding 2 here. And just like in the previous 2 examples, we were interested in the H plus because they were acids. We're not interested in this SO4 minus and Cl minus. In the case of this, we're just interested in the OH because it's a base. So what is the ratio here? 1:1:2. So if the concentration of this guy is 0.025, this will be 2 into 0.025. Alright, so therefore, the concentration of OH minus would be 2 times 0.025. It is 0.05 molar. Now, since we have gotten the concentration of OH minus, right, what exactly are we going to solve for first? Is it the pH or the pOH? Obviously, it's going to be the pOH because the pOH formula has OH is negative log of OH minus. So anywhere you see OH, you put 0.05. Now when you do that, you press your calculator. This becomes negative log of 0.05. So this is 1.3. But remember, you were asked to solve for pH and pOH. Alright? So this now becomes pH plus pOH equals to 14. pH, which is what I'm solving for now, is 14 minus pOH, which is 14 minus 1.3. And the answer is 12.7. Now this is an acid. Alright? That is an acid. 0.001 molar H3PO4. Now this is phosphoric acid or hydrogen phosphate acid. Alright? So let's dissociate this. If you notice, you have 3 hydrogens here. So this will give rise to 3 H plus. So we have H3PO4 giving us H plus 3 plus PO4 3 minus. Please take note of that. So we are interested in H plus. We are not interested in this because this is an acid. An acid will always give rise to H plus when ionized or dissociated. So this is 1:3:1. So if here is 0.001, here is going to be 0.001. 3 times this right? 3 times this because the ratio is 1:3. So therefore, our H plus is 0.003 molar. Alright, so when you now come here, you say since I am asked to solve for an acid, for the pH of an acid, they gave me an acid. From this acid I've gotten the H plus because the formula of pH needs H plus. So I've gotten the value of H plus, so all I just have to do is to replace this value into this formula of pH. So this is negative H plus, which is negative log of 0.003. So if you press your calculator, we have negative log of 0.003. This equals to 2.5. So pH of this is equal to 2.5, but once again, remember, we were asked for pH and pOH, not just pH alone. So we'll say pH plus this is equals to 14, which is 14 minus 2.5. This will give us 11.5. Alright, so pH is 2.5 and pOH is 11.5. Now, the last but not the least, so let me just solve this. Now, for the number 5, they gave us 0.1 molar NaOH. Now, this is a base. By virtue of having OH, it's a base. So when these dissociate, it will give rise to OH minus and Na plus. So this is we have Na plus OH minus. The ratio is 1:1:1. So this is 0.1. The value of this is 0.1, so the rest is going to be 0.1, but I am not interested in Na plus. This is what I'm interested in. I'll just put it for formality's sake. So therefore, concentration of OH is 0.1 molar. So since I have OH, what I am going to solve for first is not going to be pH, it's going to be pOH, because pH has H plus in its formula, whereas pOH has OH minus in its formula. So the one I'm going to use is the one that has what I have here. So I will say pOH is equals to negative log of OH minus. So this becomes negative log of 0.1, which is 1. Alright, so you now say pH plus pOH is equals to 14. pH equals to 14 minus pOH. So this is 14 minus 1. And the value for your pH is 13. So having done this, we've actually completed the first 2 cases of calculations under pH. The last case is actually that of a weak acid and a weak base. And of course, that is more little complex than the first 2. But if you actually understand the concept behind the first and the second, the third one, I'll give us a shortcut. You don't really need the necessary stress, but I will explain and tell us how you can go about it, and then follow it up with the short method to solve it. All right, please, if you're new to this channel, please do also hit the subscribe button, right, and share the video. Thank you.